All right, cool. So session 7, we are almost done. There are 9 sessions in total, so we're getting there. Oh, there's a chat question here. It says I need permission. Yeah, I don't have an issue with you guys recording if you want to, but I think Zoom doesn't let you do it by default. And honestly, I'm not 100% sure how to give you guys permissions to do it. But I will, upload the recordings that I make just as well. And if you're able to record it with some third-party software, go ahead. All right, so I'm gonna put this in full screen right here. Session 7, September 6th, and I do believe that is today's date. Truthy Falsey. So Truthy Falsey is an idea in programming and specifically in JavaScript as well. That means that every value, regardless of its data type, can be converted into a Boolean. It has some Boolean representation. And this is known as the truthiness or falsiness of that value. So obviously false is false, right? So it's like if I take a Boolean, it is what it is, right? But if I give you a number like 0, we're going to say that represents false, or 1 that represents true. And that's a very common thing you'll see in other languages as well. It's actually kind of a standard that 0 represents false. An empty string is the string equivalent to something that could be interpreted as false. Null, undefined, and not a number. When I ask, does it equal false, without a strict operation, like I give it 2 equal signs instead of 3, it's going to say that's false. Yeah, it is. On the flip side, there's also things that are truthy. It's not true, it's truthy, which means it can be interpreted as though it was true. So a string that contains a 0 is true, which is, a little counterintuitive because 0 as a number is false, but as a string, it's true. And that's just because any string that isn't empty is going to be interpreted as, truthy. Similarly, if I have a string that says false, that's still going to be interpreted as true because it's a non-empty string. So that's the rule for interpreting strings as whether or not they're true and false. Actually, how about I just open up a REPL real quick to show that the fact that is in fact what it looks like. So let's just want to access console really easily. So if I made a string and I said it's false, I don't want to say, is it true? It'll say, no, it isn't. It's actually false. So I can say, is it false? And it'll say, yeah, well, it's not false either, but it can be interpreted as false. So if I had an if statement with false in it, like if false, I can say console log false. So yeah, it did in fact console log false because it interpreted false as if I had given it a true Boolean value. Although it's not literally true, it's truthy. Similarly, an empty array will be interpreted as true, and an empty object is true, or a function with nothing in it will be interpreted as true. So this is just the way that JavaScript determines what is and is not interpreted as true. And obviously, these rules are going to differ slightly between languages. In fact, the concept of interpreting something as true kind of breaks down in certain edge cases like this and a lot of other languages. They'll just say, well, that's not a Boolean, you can't do that. But JavaScript's pretty flexible in that regard. You just have to learn these confusing rules about how things are represented as true and false. And again, you're not expected to memorize this, and you don't necessarily need to have like an if statement with a string in it. Like there's other ways around that without utilizing falsy and truthy. It is an important skill to have in your arsenal. All right. Are there any questions on what truthy falsy is? No? All right. Moving on. Our second topic for today is recursion. All right. So recursion is the process in which a function calls itself. And we've given examples earlier of functions that can call other functions, functions that can work with other functions in sequence. But this is when a function refers to itself with some different set of arguments. So here we have a function that says sum up to. And in it, at the very first, I say, well, if the number is 1, I'm just going to return 1. That's it. I'm done. But otherwise, I'm going to do something special. I'm going to take the number that I was given and then take the result of summing up to with the number 1 less than I have right now. So this is the common way that you will see a recursive function built. It has 2 parts. One's called the base case, which is a situation where it exits, no questions asked, doesn't do any recursion there. And there's one that's the recursive case. And you can imagine if this base case wasn't here, it would just keep calling the function forever, because every time the function's called, it's like, call the function again, and it just keeps on going. So using recursion requires two cases. One is a base case, the condition in which the function stops calling itself and returns a final result, and the case in which the function returns itself. So let's take a number 3, for example, sum up to num3. I can go to the recursive case, and it's going to return 3 plus the sum up to with 3 minus 1, which is 2. So we're returning 3 plus something, so we know it's at least 3. Okay, cool. So now we're looking at sum up to with a 2 inside, because that's what we just called right here. 2 gave us, well, that's going to be 2 for the first one, and then a 1 for the second one. So sum up to of 1. Okay, so now we go back, and num1, that's just going to return 1. So now we go back, and it's going to be 1 plus 2 from before. Then we go all the way back. What was the result of the first sum up to of 2? And that's going to be 2 plus 1, which is 3. So then you add 3 to 3, and it should give you 6. And unless I'm bad at math. Yeah, it's 6. We're going to go over the steps in more detail in the upcoming slides, but this is the idea of recursion, and it has these 2 premises in here. You're able to do everything that you could with the for loop using recursion. Like we just went over numbers 1, 2, 3 by just calling the function over and over again. And any kind of problem that you can represent with the for loop can also be represented by a function just calling itself over and over again. So that's called the recursive versus the iterative approach. And you're going to see them both in the real world quite a bit. And sometimes one is more efficient than the other, and it depends on the nature of the problem you're working with. Right. Are there any questions on what recursion is? Right. We'll explain this particular function case in the upcoming slides. So here we have an example where we have 5. The original call, I said let result equal sum up to 5, and it console logs the result, and we get 15. But there's a lot going on inside of that. So we can go to the first instance where we called it. The number is 5. So now we're checking if num equals 1. So is 5 1? No, it's not. So we ignore this and move on to the else case. So it's going to return the number plus something. So that's 5 plus the sum of up to. So I'm calling the function again with 5 minus 1 because our 5 was the number, right? So now we go to the next function call. Oh, my bad. We go up to the next function call. And here we're giving it 4 because we called it with 5 minus 1, which is 4. So now we do the same question we asked before. Is 4 equal to 1? No, it isn't. So we're going to go to the else. We return 4 plus the sum up to a 4 minus 1. And we keep repeating this. And eventually we end up with a case where it's 1. When it's 1, it just returns 1. And you can imagine this 1 replaces this little thing right here, sum up to 2 minus 1. Just imagine this becomes a 1, right? So 2 plus 1 is 3. So sum up to 2 is going to return 3. And that's what's coming up here. So you can replace this with a 3. So it bubbles up the call stack. So this is 3 plus 3. Okay, that's the result of sum up to 3, which is 6, which we explained earlier. So now we know the result of sum up to 3, which is required to calculate sum up to 4. So it's going to take 6 plus 4, which is 10. So sum up to 4 is going to return 10. So now I plug that into this top one at the very beginning of our call depth, and that's giving me 5 plus 10, which gives us our final result of 15, because now we've gone up all the calls and returned the result for every single one of them. But you can see if we didn't have that base case, it would just keep calling it, and the call depth would become infinitely deep. And as a result, it would never return because it's still trying to resolve all of these function calls. Right. So the result of sum up to 5 is to compute 5 plus 4 plus 3 plus 2 plus 1. And if I gave some other higher number, it would just be from 10 up to and including 1. So this is an example of how we use recursion. Right. Are there any questions about this process? Anything that you want me to explain? All right. Can you all hear me okay? I'm not entirely sure if you can hear me all right. Just all right. Okay, good. So that is the result of this session. We talked about Truthy Falsey and we talked about recursion. So why don't we get started with an exercise called Blackjack? Let me just open it up. Blackjack. So the question is this, we're going to work on some recursion questions later today. We're just going to start with something a little bit easier to warm ourselves up. So given a number representing the sum of the cards in your hand in the game Blackjack, you need to write a method that returns a string that is the appropriate response in a game of Blackjack. And I assume that most of you are familiar with Blackjack. The objective of the game is to get as close to the number 21 as possible without going over. And in the game, you have, you take the sum of the cards that you have been dealt, and you can request more by saying, hit me. And you can say stand, I'm done. And bust means you went over. So here, they're saying that there's a certain range in which it's most appropriate to choose to hit or stand. And, busting is just kind of what happens. So if the sum of the cards in hand is less than 15, we're going to say that you should hit. If it's between 15 inclusive and 21 inclusive, then you want to return stand, which means stop hitting. Don't put any more cards down. And if the sum is greater than 21, then you return bust. Right. So this is a simple control flow problem. You do this with an if-else kind of system. All right. I'm going to put this in the chat unless there are any questions about Blackjack or this particular problem, what it's asking of us. Nope. I don't see any questions. I'm going to put this in, and I'm going to put the time on the clock, online stopwatch. I'm going to give us 10 minutes for this one. All right. And I'll see you then. All right. So Blackjack. Let's head right here. So the first situation is that the value is less than 15. We can return hit. So I can say if sum is less than 15, we can return hit. Now I can say else if the sum is greater than equal to 15 and it is less than equal to 21. So I can say and sum is less than equal to 21. Then let me just move this over a little bit. There we go. Then I can return, we should stand. And lastly, no matter what happens, in this case, they're saying that it must be greater than 21, because it's not less than 15 and it's not between 15 or 21. So it must be greater than 21 by process of elimination. So you don't need to say else if sum greater than 21 here, because that's the only situation it could be in. So here I could just say return bust. Now let's take these and make these our tests to verify that it is in fact working the way we believe it should. So I'm going to select. I'm just going to console log this. Oh, hold on. There we go. Oh, and these should be strings for our comparison. And I'm going to click run, and we should see they're all true. Great. Do we have any questions about this problem? No questions? All right, moving on to the next one, repeated characters. Repeated characters using arrays and loops. Yes. So the purpose of this is to write a method that takes in an array of characters and a similar length of integers. So here we have an array of 3 strings, A, B, and C. And here we have an array of the instances in which they should occur. So we're going to have 1 A, 2 Bs, and 3 Cs. A, B, B, C, C, C. So we have to return that string consisting of every character repeated the number of times as indicated in the integer array, with each character corresponding to the number in the same position. So here we say 1H, one E, two L's, and one O, and that gives us hello. All right. Are there any questions about what this problem is asking us? No? All right. To clarify, you do not need to use recursion for this problem. It's just going to use arrays and loops, although this problem could be solved with recursion, and I'm not going to tell you can't do that. I just think that this is a problem that you're better off using iteration 4. All right. So I'm going to send the link in the chat. 1 second here. And I'm going to put the time on the clock, and I will see you in 15 minutes. All right. So copying over the tests. And I'm just going to make this a strict equality. I'm going to go here and I want to console log my results so I can make sure that they are in fact returning what they should be. Great. Can I just hide this real quick? Or, nope. Okay, that's fine. This is good. I'll just make it a little bit smaller. There we go. So repeated characters. So why don't I go over the solution with built-in methods first? So one thing you know is that this is going to be the number of times in which this value must be repeated. In JavaScript, there is a built-in function called repeat, which can actually duplicate instances. So if I had the letter A and I say dot repeat, I want it 5 times. It will give me 5 of them just in succession. Alternatively, you could have made a for loop and just concatenated to a string. So I could say my string equals, an empty string. And I can say for let I equal 0, I is less than 5, I plus plus. And then I can say my str dot concat A. And in doing so, I added A 5 times. So now I can look at my string and, oh, did I do that right? I is 0, I is less than 5. I'll say I plus plus. So if I say my string dot concat A, oh, okay, I actually have to set my string equal to the concatenation. So I got to head on back here. Oh, what's going on here? Okay, I'll do it over again. For let I equal 0, I is less than 5. Oh, I plus plus. And I want to say my string equals my string dot concat A. And there you have 5 of them in succession, saved to a string. Oh, yes, we are recording. So that's basically how you would do the dot repeat built-in method using a for loop. You could just concatenate 1 at a time. We're just going to use the repeat method for that. But we have to do that for every single one of these. So you could have another for loop saying go through every single one of them and find the corresponding number. And that's the number of times in which the inner for loop must run, or the value which I pass to the dot repeat method. So let's say here, I have the character array. And I want to say for every value in the character array, I'm going to replace it with a certain value, which is going to be the current value in that position. And I want it to be repeated with the index in the number array, which I know has the same number of lengths. So I'm able to access 1 from the number array for every value in the character array. Now, fortunately, mapping does allow me to access both the value and the index. As we can see here, it takes a callback function that takes a value and optionally an index. So here I'm going to call it, make a fat arrow function that takes a value and an index. I'm going to call it v and I. And I want to say that for the value in question, I want to get the, one thing I want to do is I need to find the index of the location so I know where to find the number array. So I want to take the value I have here and I want to repeat it a certain number of times. How many number of times? That's equivalent to the number in the number array. So I can say look in the number array for the value at index I. Because here, let's say I'm looking at the first one. I'm saying I want to repeat A as many times as, okay, we're looking at the first one in the number array, 1. Repeat it once. That just gives me A. I'm looking at B. Its index is at 1, or the second one rather. it's going to repeat it, whatever value is the second one in the number array, which is 2. So it repeats B twice. So that should give you all the values, but it's going to give you an array because that's the result of the mapping. So I could join the result into one big string, and I can return this. And let's see those results, see what it looks like. It returned true. So that means we did in fact get these particular results. Good. So this is the solution using a mapping and a repeat and a join. Are there any questions to this particular solution? No? All right. So now we can go to the variant that uses a for loop. All righty. Oh, there is a question here. Would we need to compare the lengths beforehand? That is a good question. I would say that it's fair to assume that the inputs are correct, that they both are the same length. As if we look at the instructions here, it says it takes a similar length array of integers. So that means that you should have sufficient integers to actually do this problem. But you could very well check, say, if character array is larger than the number array, then we have a problem. We don't have enough numbers to actually pass to the repeat function for every value in our character array. So then you could throw some error or something, depending on how good you want this to be. This is a perfectly valid solution without such checks, though. All right. So now, alternatively to a map, thank you. Alternatively to a map, you could use a for loop. So I could say and I want to go over everything in the character array, but I'm not going to use an of loop because I still want to get the indices of the character array. So I can do the classic let my index equal 0, I is less than the character array, length. So I want to go over all of them and increment by 1. So now I'm able to access the values by indexing at I in the character array, and also use I for the index. So using this kind of loop, I'm able to access both the values and the indices, as opposed to a for of loop, which would only give me the values. I can't quite hear you, Lewis. Okay. So from here, we could also create a for loop for the repeat. Alternatively, we could use repeat within this for loop. I can show you that solution first and then move on to the version that only uses the for loops. So here I can say for each and every one of them, I need to have a result. And I guess I could store that here. My result is an empty string. And I can say I want to add to the result. And you can use plus equals or you can use concat. They do the same thing. Res plus equals, which means add onto res and then store it in res, which stands for result in this instance, by the way. I want to place in it the value, which I know to be the character array indexed at I, because that's the one in the character array we're looking at right now. And I want it to be repeated by the number array at I as well. So this is the version that uses repeat. And then I still need to return the result. And if I run this, I should see true. So it worked. All right. Any questions to this particular solution? Nope. All right. So let's say we didn't have the repeat method. How would we do this? We could make another for loop inside that has the same result of what a repeat does. So I can say for let j, because I can't call it I because I already have that in the outer for loop. I'm going to say j equals 0. And j is less than the value of the number array I. So num array at I. I want to increment j. And then I want to say res plus equals the character array at I. And if I run this, I get the same result. It works just fine. So even if we weren't aware of maps and repeats, we could have done this purely with for loops. Any questions to this solution? Nope. All right, then I will just delete this and move on to the next problem. And I don't know if I erased from the blackjack problem. Yeah, I have to delete this too. Great. So our next problem is, oh, this one's actually going to start using recursion. It's called pyramid. There you are. Pyramid. Let's just erase these. Our tabs are getting a little cluttered. So using recursion, you need to write a function that returns the total number of blocks in a pyramid with a given height. And the pyramid looks like this. In the first row, we have these little, as we add rows, it just gets bigger and bigger, and it adds one more asterisk to each end to make it 2 larger than the previous. So the number of blocks for each row, n, is going to equal 2 times n minus 1. So for row 1, we have one of them because 2 times 1 minus 1 is 1. For row 2, we have 2 times 2 is 4, minus 1 is 3. So we give you 3, which means I added 1 to each side. And we can repeat this for any n. So you need to find out the total number of blocks, which is the sum of each of these, 1 plus 3 plus 5 plus 7. So the pyramid of 3 is 9. That's going to be 5 plus 3 plus 1, 5, 6, 7, 8, 9. And you have to do this using recursion. Right. Are there any questions to what this problem is asking of us? Okay. Take care to remember that a recursive solution requires a base case, which is a condition in which to stop calling the function, and one which uses the function call in question with a different parameter, so that it doesn't give you the same results every single time. Right. So I'm going to put this question in the chat. Feel free to refer to the slides and their example of how you would use recursion, as well as any online resources you might find. I'm going to post this in the chat right now. I'll put 15 minutes on the clock. I will see you then. So like I was saying, you must create a base case first and foremost, and setting 1 as our base case is most reasonable here because that is the least number of rows that one can have. So if I said, what are the number of blocks in a pyramid of height 1? It's just 1. So I can return that immediately. I don't need to make any recursive calls to get that result. So I can go here and I can say, if height equals 1, return 1. Great. So that's our base case. Now, going beyond that, let's say I had a height of 2. I need to compute the number in the row 2 and then add the result of row 1, which means I'm going to be going with height minus 1. So I'm going down 1 level of height. And equivalently, that would happen if I was on row 4. It would take the number in row 4 plus the number in row 3. The number of row 3 onwards is going to take row 2 takes row 1, and it just bubbles up the stack. So here I can say, I don't have to say else here because it's the rest of the control flow. If this didn't happen, everything else below it is going to happen regardless. So I can say, I want to return. First, I have to get the number of blocks in the current row for height. And that's going to be 2 times our height minus 1. Actually, I can make this a little prettier. And then I want to add to it the result of pyramid on height minus 1. And let's use this example as our test. And we're expecting to see 9 for a pyramid of 3 because 5 plus 3 plus 1 is 9. Just move this out of the way and click run. And we get 9. So we see that it is in fact working. And remember that here I give it 3. This base case is ignored. So it hits the recursive case every time until the height is 1, in which case it simply returns 1. So here we get the number of, for the number 3, we're getting the number of blocks in the 3rd row. And then I want to add it the results of everything else, assuming that it was a height of 2, right? Because if I had a pyramid of height 2 and I added one more row, that's a pyramid of height 3. I can keep doing that. So this is a result that depends on the results of a different subset of the same problem. So I can just break it down in this way. Are there any questions about this particular solution? No? All right. So let's say I wanted to solve this iteratively. And like I said, any problem that can be solved recursively can also be solved iteratively. although the purpose of this is to demonstrate recursion. So one thing I could do is I could keep a counter. I could say let my result equal 0. And I want to iterate over all of these rows that I have. So I can say for let I equals 0, I is less than height, I plus plus, and I can say I want to add to res 2 times I minus 1. And then I can return the result. And if I run it, oh, hold on, did I do something silly? Yeah, it's, oh, because we're starting at 1 less than equal to height. Yes, because rows start at 1 in our formula. So I run this, I get 9. So you can see any problem, and this is it's not always obvious. There is a formal proof for whether or not a recursive problem can always be represented as iterative and vice versa. However, that is we're not going to go into the proof on that. Just know that it is the case. Any questions? No? All right. So moving on to the next problem. My coworkers. This is an arrays and loops problem. My coworkers. Oh, I should delete this. All right. So in this one, you are given input in a nested array of colleagues. So this is our input. It's just a globally accessible array of arrays. Within the nested array, there are your colleagues' titles and a characteristic of them. So you can see here we have information on these people: Stacy, Jim, Jenny, and Corey. So the first element of this array, the first element is an array, and the first element of that array is the name Stacy. And the second element of that same array is an array itself, which contains IT person and super smart. And these are descriptors of Stacy, because Stacy is an IT person who is super smart. Similarly, we have information pertaining to Jim, Jenny, and Corey in this way. So we need to write a function that console logs the colleague's name, title, and their characteristics, and then returns true. So remember that console logging is not the same as returning. Returning is I could replace the result of the function call with that result and use it in other equations and other function calls. Whereas console log is simply printed to the console screen for us to see. All right, so the objective is to take this information and print it out to the screen in this way, where we take the name, Stacy in this case, and instead of just saying Stacy IT person super smart, it says Stacy is the IT person and is super smart. And it does this for everybody. And then after it's done that, it returns true. Any questions about this problem? Nope. Then I will post the link in the chat. And I will see you all in 15 minutes. All right. So we are looking at my colleagues, or my coworkers rather, whatever. So what we need to do is, this is really more a question of how to parse arrays of arrays than anything else. So we can do this with a for loop. So I can say for, oh, well, we can, let's see if we will. For let I equal, actually I could do a for of loop for this as well. So how about I just do that? So I'm just going to say let call for colleague of colleagues. And inside of it, I want to make some variables just to make it easier for me to read stuff. I'm going to make a constant called name. And I know that's always going to equal the first here. So just, each call in colleagues is each of these individual arrays in the colleague data array itself. So each call is itself an array. And I know the first one is always the name. So I'm going to call that constant just so it's easier for me to read. I didn't need to do this. I just think it makes it easier, and making readable code is good. So the next one is your job. and then it's your description. So you're an IT person, you're a salesperson, you're a manager, you're a software engineer. So the job is, so now we're looking at the second one in here. So that's called 1. That gives us the second half, but I want the first half of the second half. So I have, because remember, this is itself an array and therefore can be indexed, and I shall do so like that. Similarly, if I want their description of like who they are as a person, I want the second half of the second half. Great. And now I can console log it. And let's do that right quick. So I want to say that name is the job and is, and this one is going to be their description. And then there's a period at the end. Cool. And then after all that's done, you return true. Great. So now we can run this and see what we get. Oh yeah, I have to call the function first, don't I? So let's go down here and say I want to run my colleagues with colleague data. Also notice that here, the template provided us a fat arrow function that is equally valid to just using the function. So I'm gonna click run. Yep. So Stacy is the IT person and is super smart. Jim is, so it is formatted correctly and it returns true. Right. Are there any questions about this? No? All righty then. Then moving on to our next problem, we're going back to recursion. This is called factorial. There you are, factorial recursion. This is a very common problem in recursion. It's a very popular problem, you'll see. There are many ways to solve this problem, and the more naive, it's called the naive approach. It's the one that's most immediately obvious. It's usually not the fastest one available to us. So there are many different ways to compute factorials. There's not just one solution to this. I don't expect that your solution to be fast by any means. So if you plugged in a really big number, it might be really slow. That's perfectly acceptable. So a factorial is a mathematical function that takes in a positive whole number and returns the factorial of that number. So what is a factorial? A factorial is the multiplication of numbers, integers, from 1 up until a certain number. So 3 factorial, written as 3 exclamation mark, is equal to 1 times 2 times 3. 5 factorial is 1 multiplied through 5, and so on. Right. So we can solve this using recursion. And do we have any questions as to what this problem is asking of us? Nope. If we don't, I will share this link in the chat. And I'll put 15 minutes on the clock, and I will see you then. Okay, as I was saying, you can take a factorial of 0, and it is also 1. So you can say 3 times 2 times 1 is the same as all the other equations. But for this particular problem, let's just assume that we're going to have a base case of 1. Okay. So many valid implementations. And since we're only operating on these 2 test cases, I think that's perfectly fine. So let's say if num equals 1, we return 1. Because all the numbers from 1 through 1 inclusive, it's just 1. And the product of just the one number is itself. All right. So moving on to the recursive case, we have to take the number in question and multiply it by the factorial of the number below it. Because I could say that, 5 factorial equals 5 times 4 factorial. Because what is 4 factorial? 4 times 3 times 2 times 1. Right. So look at here. Here we have 5 factorial. Within 5 factorial, we have 3 factorial. 1 times 2 times 3. Then we add a 4 times the 5 after it. So that means that 5 factorial is really 5 times 4 factorial, or 5 times 4 times 3 factorial, and so on. So this can be broken down into subdividing the problem into simpler instances of it on, smaller numbers. So here I can say I want to return, well, the number in question, that's num, multiplied by factorial on num minus 1. And it's going to keep decreasing up until it reaches our base case of 1. Again, you could have just as easily said, if num is 0, return 1. Actually, let's do that and see that we still get the same result. And let's get rid of this little comment here and copy our, let's just use this as a test. And we should expect to see 120. So I run this. Yep, I get 120. And if I give it factorial of 10, it'll give me a really big number. And if I give it a really big number, it's going to be so slow. We'll probably crash the browser. So let's not do that right now. Factorial of 1 is 1, and factorial of 0 is 1, as we've defined with our base case. But here's an interesting thing. What if I gave it a negative value? Let's say I give it the factorial of -1. It's going to run forever because our base case will never catch it, because our recursive case is always decrementing the number. And if I decrease from a negative number, it's going to keep going down because it never reaches 0. So to solve this, instead of saying it's equal to 0, we could say if it's less than equal to 0, return 1. Oh, yes. So now if I gave it factorial of 0, it's still going to return 1. If I gave it a factorial of 120, my bad, 9. Was it? My bad, it was 5 that we were looking at earlier. It's 120. Yes. And if I gave it a negative value, it's not going to break. Although realistically, taking a factorial of a negative number is kind of nonsensical because you can't go down up to 1 from a negative number. But I digress. That is the recursive solution to the factorial problem. And as I said, all recursive solutions have an iterative approach, which is equally valid. Are there any questions to this particular solution? No? All right. I'm not going to do the iterative approach to every single recursive problem, especially as the recursive problems become much more complex in nature, as it's a different way of thinking you have to get yourself into. And I don't want you to use iteration as a crutch when you're trying to learn recursion. Right. So moving on to the next problem here, we have reverse word, which is another recursion problem. Well, first, let me just clear our comments from our last solution. All right. All right. So using recursion and without creating any additional variables, create a function that returns the reverse of the inputted string. So here we give it hello and we get ole, or H backwards. This is mine becomes enim si sihit, or you don't have to pronounce the reversed version of it, but the idea is that every character is now in reverse, including punctuation, spaces, and capitalization. So again, you don't have to use any for loops or anything of the sort. It's pure recursion. All right. Additionally, you don't need to store any variables. It simply saves the result of what's returned through what is known as the call stack. Right. And another terminology thing, the call stack refers to the function depth that you're at. So every time I call a recursive function, it's a function call within a function call within a function call. It remembers where it's at, and then it has to return that to the previous function call, and it remembers to bubble all the way up what is known as the call stack, because it's the stack of functions which has been called. And that sequence of calls in the context in which it's called is remembered, which is why you don't need to store any variables like you would for iteration. All right. So I'm going to give you this question right now in the chat. If there aren't any questions as to what it is asking, and I'm going to put 15 minutes in the clock, and I will see you then. All right. So using recursion and without creating any additional variables or using any for loops, create a function that returns the reverse of the inputted string. So as you had probably surmised, recursion requires breaking the problem into subdivisions of the problem. And that can mean reversing a subsection of the overall string. So that can start by just giving us the last character, then adding the one after that, and so on, one at a time. So the first one is going to be the last, and then I can append to it the next one. So I can say I want to return the in order string, and I want to get the last element of it. So I'm going to slice it with -1, -1 meaning the last one. Okay, that gives me the last one of this string. So now I need to give it a smaller version of the string that does not include that last one. So the new last value is going to be what was the second last value. And I can concatenate onto it an in order string as we have, but it needs to be sliced between 0 and -1 inclusive, which means everything except for the last value. Great. So let's take a look at this and see if we did it right, first of all. Oh, and the base case here is actually kind of implicit. Actually, no, it isn't. I have to give it a if the string is empty, in order string is an empty string, then I just return an empty string because I don't need to slice it or try to get the rest. Otherwise, I'll just keep slicing indefinitely, and I'll keep slicing this empty string. And let me show you, yeah, implicit is not in fact what this is, nor is it something that we would ever do. So here I had a string, and let's say I want to slice it, get the last one. The last is the same as the first. And so everything excluding the last is just going to be the exact same string. So we'll just keep doing this indefinitely, which is why we need this base case. So if it's equal to the empty string, you return the empty string and it will just stop. Every other time, like if I had a string like hello, we get the last one, slice -1, gets us O, the last one in hello, and 0 through -1 gets us everything except for O. And then similarly, we just do the same process, get the last one L, get the rest HEL, and it does this one at a time for prepending the value of what was the last. All right, so I'm going to give this a run. And I got, oh, okay, let's see what we did. Oh, you know what I did wrong? I have to give it the reverse word of this. All I did is give it the value immediately. So I need to have a recursive call on reverse word with this. Silly little mistake right there. Give this a run. And we got hello backwards. Cool. I could give it another string like this is mine. And you'll see that it has been reversed. This is mine if I read it backwards. And if I give it an empty string, it returns the empty string immediately because the reverse of an empty string is itself an empty string. Great. Are there any questions about this solution?
Yeah, okay, I got a question. So I understood everything to the point where like you at first you entered it, but how did you reverse it? Like the remaining string besides the first one.
So the first thing is, imagine we take the last letter of the existing string. Like I have hello, right? I have hello. And actually, this is not the right place to ask it. I'll just type it here. I have hello, right? And I take the last one, O, and then I'm going to add to it the rest of the thing that needs to be computed, whatever that is. Now I ask the same question. Jesus, yeah, this is annoying. I have hell, which is another word I want to do it. So basically find the reverse of the word within the word, right? And that's going to be L plus whatever. And it does that for every single one of them. And then you have E, and you're going to have another L, and then you're going to have an E plus everything else, plus a E plus an H, all the other ones being added to it. And once it resolves the final one, which is an empty string, it's just going to be that value. So the empty string concatenated to it, which is itself. So then, okay, because this is concatenated to the result of E, it's going to be E, because I do O before L. So O, then L, then L, then E, then H.
Okay, but I saw you, okay, I understand that, but I saw you put reverse word and then parentheses. How did the reverse word itself like reversed hell?
Okay, the exact same way that it returns hello. Imagine here, I wish I could show you like a diagram or something, or like a flow chart like I did in the slides. I don't have one ready, but the idea is here, it takes the last letter first. And the last letter of the I take a substring of our original string, which excludes the last letter. So the new last letter is what was the second last letter. And that repeats for the third, the fourth, the fifth. And it's prepended, because here, the result of what's currently the last comes before the result of what was the last. And I can show you, if I put this at the end, it's not going, the order matters, right? The order in which I add it to the thing which I'm returning. If I put it at the end here, it's just going to give us, well, this is empty string. If I give it something to reverse, it's just going to give us the initial string back. The order in which I prepend it matters. Yeah, so that's all it is. It's because I'm taking the return value of that function and that's being plugged in to the return value of the function above it.
Okay.
Cool. All right. So we're going to move on to the next problem, largest error. Let me find it real quick. Largest error. All right. So we need to write a function that takes a list of so-called incorrect numbers and a singular correct number. And we need to return the incorrect number farthest away from the correct number. So here, our correct number is 0. And the difference between here, this is 3 apart, this is 6 apart, and this is 10 apart, because that's how far away that number is from our so-called correct number. So we return the incorrect number that is farthest away. All right, and this is not a recursive problem. This is solved using arrays and loops. So do this with arrays and loops. All right, I'm going to place this in the chat, and I will see you all in about 15 minutes. I'll put 15 minutes on the timer. All right. So as I just said, forgot to start recording. We take the absolute difference, the absolute value of the difference between the correct value and each of the incorrect values to find how far apart they are. Because if I take the difference between two values, one is going to be potentially bigger than the other. And as a result, depending on the orientation of the subtraction, we might have a negative distance, which is a bit of an absurd concept in this context. So we want the absolute value of it so that regardless of the order in which the subtraction occurs, it does not change the distance between those values. We then need to identify the largest value, the largest one of those distances, and then return the incorrect value to which that distance was attained. All right, so that is the algorithm in question. All right, so what I can do is I can map over every single one of the incorrect values the corresponding distance between the correct value and each respective incorrect value. So actually, let's yeah. So I can take our wrong numbers array, and I want to map onto each and every one of, actually, I'm not going to do that right here. I guess I can just say distances. And I want to map onto every single one of them the absolute difference. Actually, I have to make a function to take this. So we'll call it a num, and each num takes the absolute value of the difference between that value and the correct number. So those are each of the distances. Great. Now we need to find the largest one. And there's a built-in method for that. It's called math.max. It finds the largest one, but it gives us the largest distance, but not, we don't want the largest distance necessarily. We want the largest incorrect value through which that distance was obtained. So to do this, we can actually find the index at which this largest distance was found in this mapping, and then, index the wrong nums array to actually retrieve that value. So if I were to take the max of our distances, we'll get some number. And I guess I could say that's the max distance. All right. So from this, I honestly don't think this constant is entirely necessary, but regardless, I have the maximum distance, and I need to find where it occurred. And there's a find index and index of, which will find the first instance in where a certain value is found. So if there's multiple equally far apart values, it's going to choose the first of them. So let's say here I have, 1, 2, 3, and the largest value, and I have to consider it with 0, for example. The largest distance is 3, so I want it to tell me it was found at the index 2. So I say I want to find the index of 3, or index of 3. And to clarify the difference real quick, index of just takes the value I wish to look for, whereas from index takes a function, which allows you to do some more complex operations. But for our intents and purposes, we're going to focus on index of. So I can say I need to find the actual location where I can find the wrong number that got us the maximum distance. So I can say from our distances, we want to find the index at which our max distance was found. And then that is the index which we wish to retrieve from the wrong nums. So I say wrong nums at that index, that gets me the wrong number that was so far, that gave us the largest distance. So we can simply return that value. So let's go down here and take this one, for example. It should return -10. I run it. Oh, let's see. Oh, one other thing I forgot to mention. Math.max takes a spread of the values. It doesn't take an array. So if I had math.max of 5, 2, 7, 1, it's going to return 7. But if I gave it an array of these values, it'll complain. You know, that's an array isn't a number. It expects each argument to be a number, and it compares all of its arguments. So I want to, and spreading it is the same as just getting rid of those little brackets at the end there. So that's how I would use math.max on an array. So now if I run this, yeah, I get -10. And similarly, if I were to give it these parameters, I should expect to see 6. And we do. Okay, are there any questions about this particular implementation, this particular solution?
Can you explain the notation for wrong nums and then you have the bracket on line 5 for return?
Okay. So a mapping is when you associate a certain value with each value in an array. So I know I have all of these wrong numbers, right? And I want to, in its place, find the absolute value of the difference between that number and the correct number. So in this case, it would actually be the exact same result. But let's say our value was like 2. The difference between 1 and 2 is going to be, well, 1. Here it's going to be 0, and here it's going to be 1 again. And it's going to choose the first one. So that, what I did is I just replaced all the values with their distances. And that's what a map allowed us to do. And this is the function I'm passing it, telling it how to replace the values. It's a function which takes the number, which is the number at each of these positions, 1, 0, 1, or previously 1, 2, 3, and it replaces it with the following. And it uses, you know, the absolute value of that number in question and the correct number. So this is the simple fat arrow notation that we used. We could have just used a function that takes a num and then does something, but we use the fat arrow notation. It's very common to use fat arrows as callback functions in methods like this, with like mapping or other such things, because it's a lot cleaner, but it's just a matter of preference.
I meant just line 5 where you have wrong nums and then bracket.
Oh,
I'm not
I'm
familiar with that
okay.
Syntax.
Yeah, there is a lot to unpack here. When I got all the distances and then I found the largest of them, but I don't want the largest distance. That's not what I'm returning. I'm returning the wrong number from our wrong number array, which gave us the maximum distance. So what I'm doing here is I'm saying, look at our distances that we've computed. And I want you to find the first one that gave us our known maximum value. So this is telling me the index, where it's located in the array. So here I can say, you know, index.
Oh, I get it
1.
now.
I want to find
see
the
what I
first
was.
one. That's at index 0. And then I'm saying I want to index this original array. If I had 1, 0, 1 at index 0, it would give me 1. So it gives me the value in the first position. That's what I'm doing here.
Gotcha. Yeah. Thanks.
All right, sweet. All right. Similarly, there is a less functional approach. We could have used for loops here. So let's go here and get rid of all these maxes and maps. All right. So one thing I could do is I can say, I want to record the value that gave me the maximum distance, as well as the maximum distance we have presently. So I can say max distance, and here we're going to say it's -1 because that's just a placeholder to say, even if I found 0, that's going to be bigger and it'll update it. And similarly, I want to know what the number was that gave us this distance is. So I'm just going to save it. And actually, I don't even care to define it at this point because I'm not doing any comparisons on it. So let's say I make a for loop and I want to go over all the wrong numbers. But I actually want to keep the index where it was found, because that's because I have the distance in question, which I'm using to compare. And I also have the number which gave us that. Actually, come to think of it, I don't even need to store the distance. All I need to do is store the number that gave me that maximum distance. And I can do this operation of finding the maximum distance in a map.max on every iteration. So let me explain to you what I mean. I make a for loop, and I'm going to go over all the wrong numbers. So I'm going to say let I equal 0, and I is less than wrong nums dot length, I plus plus. From here, I can say I want to find, I'm going to ask the question, is this value at wrong nums going to produce a greater distance? So I can say wrong nums at I minus the correct number. And I need to get the absolute value of it. There's no way around that. I need to get the absolute value of it. You could make your own absolute value function by saying, like, if it's negative, then make it positive. Yeah. And if this is in fact greater than our previously stored maximum distance. And the reason why I said you didn't need to store the maximum distance is you could just do the same computation on the number to retrieve the maximum distance of that. But at this point, you're better off just making a function called maxDist that I can use. So I could say function, get dist of it. Maybe they'll make it just a little bit easier. And it takes a number, and it's going to return the absolute value of the number minus the correct number. And that's an easy way to get it. So now we can use that to just clean up our code a little bit. It wasn't necessary, but it's going to make it a lot easier. So now I'm going to say get distance of, in this case, it's wrong numbers at index I. And if that is in fact going to be greater than the number which we have saved, and actually I'm going to set it initially to the first value. So the assumption is the first value is the largest, and we can be disproven and then update it later on. Is greater than, num. Maybe I should give it a more apt name like max num, or the number which gave us the maximum distance. Yeah. I think this is sufficient for now, but you might want to come up with a more apt naming scheme for that. Get distance wrong nums I is greater than num. And I know I found one with a greater distance, so I want to update that num to be the wrong nums of I. Oh, and similarly, it's not greater than num, it's the distance which num has given us, which is why I made this function in the first place, to reduce writing the same code twice. So then I update our num. And after all that is said and done, we can simply return that number. All right, let's see what this gives us. Oh, what I do? I is not defined. Oh, I put this. This is not what it should be. This should just say the first one. Right, that gave me 6, which is in fact the correct value. And if I gave it this one, I should expect to see -10. And I do. So yeah, that is the iterative solution, a much longer. I preferred to use the more functional approach. Any questions about this particular solution? No? All right, I'm going to give us actually a 10-minute break would bring us to our time of 7 o'clock. So I'm just going to let you guys leave early. All right, let me stop the share. Stop the recording.